Hey, this is the homework help video for the spring final review, and this is the Unit 8 video for trigonometry. So we're going to start with number 2. So for question number 2, I want to solve for x. So I'm going to go ahead and mark the x and then label the sides that have labels on them. So 6 is the opposite from x, so this is opposite. And then 12 is adjacent to x, so this would be adjacent. So I want to try to use the trig function that has the opposite and the adjacent side, and so that would be my tangent ratio. So I know that the tangent ratio, so the tangent of x, is equal to opposite over adjacent, so the opposite is 6, and then the adjacent side is 12. And so now I want to isolate the x, so in order to do that I want to take the tangent inverse of both sides. So I'm going to take the tangent inverse, and if I do that to the left, I also have to do that to the right. And then I'm going to go ahead and reduce this at the same time. So 6 over 12 is just 1/2. And then these will cancel, so then I know x is equal to tangent inverse of 1/2. Okay. Alright, and then let's take a look at number 4. So for number 4, that's 320 degrees. So this is 0 here, and then 90, oops, how about 180? And then 360 to finish a circle. So 320 is in quadrant 4 then, so here's 320 here. So I'm in quadrant 4. And so remember, my reference angle is the shortest distance or shortest rotation to the x-axis. So if I want to get back to the x-axis, do I want to backtrack to the 180 or go forward to the 360? So the shortest rotation would be just to keep going forward to 360, and so my reference angle would be 40 degrees. And so I just did 360 and then subtracted 320. And so there's my reference angle. Okay. And then let's take a look at number 6. So negative 400 degrees. So negative 400, so this would be 0 now down here, right? And then negative 180, and then negative 360. So I'm going to do a full rotation and a little bit more. So that's going to drop me back down into quadrant 4 again. And so for my reference angle, the shortest distance to rotate back is just to go back to here. So which would be to my 360. So 400 minus 360 would be 40 degrees. So my reference angle again would be 40 degrees. And then let's take a look at number 7. So this one's in radians. So I know this is 0 and then this is pi. So, but I want to get a common denominator, so I want to work in denominator of 12, so this would be 12 and then 12. And so this is 12 pi over 12, and then another 12 pi over 12 would put me at 24 pi over 12. And then I have to decide, you know, which one, where is 17 pi over 12? So is it closer to the 12 pi over 12 or the 24 pi over 12? So 17 is 5 away from 12 or 7 away from 24. So that means I'm going to be over here in quadrant 3 this time. And then my distance here is just 5, right? So 12 pi from 17 pi is 5 pi. So I would be 5 pi over 12 as my reference angle. Okay. All right, and then let's go to the next page. Okay, so for converting, so let's take a look at number 16. So we want to convert either degrees to radians or radians to degrees. So this is already in radians. So if I want to convert to degrees, then I'm going to multiply by 180 over pi. So I know the pi's cancel, so let's do that. So this would be 17 over 9, and then times 180 over 1. So I can multiply straight across, or I can try to reduce first, like whatever is easier for you. So I'm going to try to reduce a little bit here because I don't have a calculator handy. So 9 goes into 9 once, and then to 180 20 times. So 9 into 18 is 2, and then I still have that 0. So now I'm just going to do 20 times 17, So that would be 34, so 340 degrees. Okay. Right. And then let's take a look at number 17. So for 17, so I want to convert to radians this time. So I want my pi on top and 180 on the bottom, and then put that over 1. And then this time I'll go straight across, so that would be negative 50 pi over 180 because the degrees will cancel. So divide by 10. And so I have negative 5 pi over 18, and that won't reduce any further. Okay, and then let's take a look at, let's do about 21, the negative, or no, let's do 20. Okay, so 5 pi over 6. So let's figure out what quadrant we're in. So that's going to be, so this is 0. This will be 6 pi over 6. So that'll put me in quadrant 2. And then I'll draw my triangle here. So 5 pi over 6 is 1 pi over 6 away. So that means my reference angle is pi over 6, which is the same as 30 degrees. So my reference angle is 30 degrees. So that means this is 30 here. So across from the 30 is 1/2. Adjacent to it is root 3 over 2, and then the hypotenuse is 1. So we want to make sure we get our positives and negatives on here. So going left, so there should be negative, and then up is positive. So then sine, cosine, tangent. So sine is opposite over hypotenuse, so that would just be 1/2. Cosine is adjacent over hypotenuse, so negative root 3 over 2. And then tangent is opposite over adjacent, so the 2's will cancel, so I'll just have 1 over root 3, and then it's negative though, so negative root 3. And there's that one. And then let's take a look at a quadrantal, so let's do maybe 24. So negative 3 pi over 2. So this is 0, and then negative 1 pi, negative 2 pi. So this would be pi over 2, so this one would be 3 pi over 2. So that means we're up here at this quadrantal, so straight up. So to get to that ordered pair, we would go over 0 and up 1, so 0, 1. So this is my x value, this is my y value. So remember, sine is y over r, cosine is x over r, and tangent is y over x. R always being 1 here. So for sine, it's going to be 1 over 1, so that's just 1. Cosine would be x over r, so 0 over 1, which is 0. And then tangent would be y over x, so 1 over 0. And if 0 is under, then we are undefined. Okay. And then let's take a look at solving. So let's jump down to the bottom here. Let's do, let's take a look at 28. So for 28, I want to isolate the trig function, so I'm going to subtract root 6. And then divide by root 2. And then 6 divided by 2 is 3, so it'll be square root of 3. So then I need to find my reference angle, so theta prime. And so I'm just going to use my 30, 60, 90 triangle, so I'll draw that over here. So tangent is opposite over adjacent, so from 60 degrees, if I do opposite over adjacent, I would get root 3 over 1, so then my reference angle is 60 degrees. So tangent is negative in quadrants 1 and 3, so now I need to find my rotated angles. So from 0, I would rotate 60 degrees to get into the first quadrant. And then to get into quadrant 3, I'm going to rotate 60 degrees past the 180. So 180 plus 60, so 240. So then there's my rotated angles. Okay, and then let's do one more. Let's take a look at number 30. Or one more on this page. So again, we're going to isolate the sine theta. So I'm going to add 4 root 2 to both sides. Divide by 8. And then I can reduce this, so 4 into 4 is once, and into 8 twice. So that would be root 2 over 2. Okay. So that would be on my 45 degree, 45, 45, 90 triangle, right? So 1 over root 2 is the same as root 2 over 2. So that means theta prime, my reference angle, would be 45 degrees. And so now the directions are wanting me to do this in radians, so I'm going to convert that to radians. So that would be the same as pi over 4, right? Because pi is 180 degrees, and 180 divided by 4 is 45, so pi over 4. And so now I want to find my rotated angles. So sine is my y value, and y is positive when I go up, so that would be in quadrant 1 and 2. And again, I want to be in radians, so this is 0, and this is pi, but I want to be matching denominators, so 4 over 4. So from 0, I'm going to rotate just pi over 4. And then for quadrant 2, I'm going to rotate here. So I did not make it all the way to 4 pi over 4, right? I fell short of it by 1 pi over 4. So that means I only made it to 3 pi over 4. Okay. All right, and then the last page on the trig unit, let's take a look at that. And let's do a cosine and a sine graph. So let's do this cosine graph. So I'm going to subtract the 1 to the other side. So my start is going to be at 0, 1, so 0, 1, so right here. And then let me highlight the midline here. So that just is finding me the midline. And then I'm going to go out into 4 quadrants, so 1, 2, 3, 4. And so now remember your cosine, it starts by moving your amplitude. So your A value. So my A is 4, so my amplitude would be 4 as well. So then I'm going to go from my shift, from my shift, I'm going to go up 4, so it's positive 4. So 1, 2, 3, 4. And then at the next quadrant, I'm going to hit the 0. And then at the next quadrant, I'm going to go the reverse direction. So now I'm going to go down 4. Next quadrant, hit the midline. And then the last one I'm going to go up 4. So remember, so the cosine graph is the one that kind of gives you that V shape, right? So the first movement is A, and then you stay, and then you go opposite A, and then you stay, and then A. And then I'm going to curve it though, right? So I want to make a half of a hill, and then a valley, and then a half of a hill. Okay. And then let's do our sine graph. Oops, hold on, my light's kicked out. There we go. All right, and then finally for a sine graph, so I'm going to do the same thing again. So I'm going to add 1 to the other side. So then my shift or my start, so that would be positive pi over 2 and negative 1. So pi over 2 is just here, and then negative 1 here. So that is just my midline, right? That's not actually graphing anything, but telling me my shift. So there's my midline. And then from there, I'm going to go ahead and mark off 4 quadrants. So 1, 2, 3, 4. And then now I want to go ahead and graph from there. So the sine graph starts at the shift, so it starts here. And then now this one, so I go over 1, and so the first quadrant, now I'm going to move up to 3 because A is 3, right? So A is 3, and my amplitude's 3. So from here up 3, and then the next point I stay on the midline, And then now for the next quadrant, I'm going to go opposite A, so down 3, and then stay on the midline. So this one is the one that does that shape, right? Okay, so we stay at the beginning, move A, stay, opposite A, stay. And then again, I want to make a hill and then a valley. Okay? And that's it for the trig unit.